I want to talk about a part, which is the polarity part of the current transformer. The idea is simply, I observed, I'm very sorry. Of course, the idea here is very simple. There is something called polarity. What is it? You mentioned P1 and P2 and S1 and S2 and those things you told us about. Let me explain it to you, even though it's a bit extra, but I also want people to know it now. There are two types of polarity in the current transformer. One type is called subtractive. And there is another type called additive. The idea behind subtractive and additive is essentially very straightforward and easy to understand. It depends on the direction of the winding of your coils. Take it from me, listen to this very well because it will benefit you if you work in protection. Here is P1 and here is what, and here is P2. Also, just to let you know, if you want to increase it, that's perfectly fine. Well, the bus bar is drawn like this, a point here in the switchgear diagram or GIS. If these two are drawn next to each other, you immediately understand that this is S1 and here is S what? S. And the red dot here is S1. So this is the primary cut and this is S1. This means the direction of the current. If the primary is going in, of course, this is closed. This case is closed on it, right or wrong? This is closed on it. So if the current is entering the dot point of the primary, it exits here from S1, meaning it goes like this in this circuit, in the S2 circuit. All right, so if I go to the additive and tell you, well, this is B1 here, and you have B2 here, and here you have a current transformer, and the dot point is drawn here like this, and I drew the dot point here on the other side. This means if the current is entering B1 here, it will also exit from here. So here it will be S1, and here it will be S2. So here the current is as if its direction is here. So of course, this depends on what? On the direction of the winding, the direction of the coil winding. So engineer, does this make a difference for me in any way? Yes, of course it makes a difference. How does it make a difference? It determines the polarity of the current transformer and consequently, this current transformer ultimately connects to a meter or it connects to protection. So how does it make a difference for me, engineer? It simply makes a difference because if I have a feeder and on this feeder, I have connected a current transformer here and connected it to a meter. This meter might be reading power or it might be reading energy, right? So if the currents in the primary are moving in this direction, and you purchased it, meaning that the currents will exit from this direction, you have brought this device for two terminals and you have connected this terminal here. Well, if you had brought yours, it means the current will be exiting from here and you have also connected the same terminal here. Okay, really, if the pilot is subtracted, if it is going like this, then the power for you is exported. Exported power going to your load, power going to your load. So the meter device sees the current entering like this on this terminal, correct? Well, if you have brought your device and connected it in the same way, then in the same direction as my outgoing power. But this time I will find that the current is actually going in like this, as if it is going out in the opposite direction. So once the ammeter will show the current entering, and another time the ammeter will show the current exiting, even though the current in the primary circuit is going towards the load or is exported in my view. But the ammeter once sees it as exported because it sees it in a certain direction, and the next time sees it as imported. That's why I need to pay attention to the polarity issue, because this polarity issue, it is short with me, or I need to be careful. If I know it, I will know the correct way to connect to my protection device. These are the two types of additive subtractions. Either it draws polarity marks for you, which puts points next to each other, or it draws them in dots or opposite from each other, meaning it draws them in reverse in the other directions. In other directions, then we come here to something written here as 12.5 30 volt ampere and 10 to 40 volt ampere. We are used to the volt ampere being apparent power, meaning it is power. Right or wrong? Correct. Well, does the current transformer provide power? It gives you current, and this current is related to feeding a specific load, and therefore the current in the load is the power. Right or wrong? Correct. So this means that this power represents the burden connected to the secondary circuit of the current transformer to climb the current E of the current transformer. 12.5, then 30 because it depends on your ratio. If you have chosen the ratio of 400 to 1, meaning you are using 1S1, 1S2, In this case, the number of windings XD only reaches a load not exceeding 12.5 volt ampere. However, if you are using the larger ratio of 1000 to 1, you can reach 30 volt, i.e. to a 30 volt ampere. All right, and if you are using the second core, the same applies. The smaller tap, which is 400 to 1, can reach 10 volt ampere, while the larger taps can reach up to 40 volt ampere. Great, very excellent.